All right, this video is about algebraic manipulation and density. So turn to that page in your notes. All right, we're going to do the 4 examples. This first equation is density is equal to mass divided by volume, and we need to solve for mass. And that means we need to rearrange this formula to where it looks like m equals and then something else. Okay, so the first thing we're going to do is we're going to find out which side the m is on, and then find out what algebraic manipulation we have to do for that. So m divided by v, we need to get rid of the v, so we have to do the opposite of that. So m divided by, the opposite is multiplication, so we're going to multiply both sides by volume. All right, volume divided by volume is actually 1. Okay, so m times 1 is equal to d times v. All right, now let's do number 2. We're solving for volume now. We need to get volume up on top. So the first thing we're going to do is divide that by 1, because density divided by 1 is the same thing as density. Now we're going to cross multiply. M times 1 is m. D times v is dv. Volume is still not all by itself. We need to get rid of the d. In order to do that, we have to do the opposite. It's d times v, so we're going to divide each side by d. The d's go away over here because d divided by d is equal to 1. And we have v is equal to m divided by d. Next one, number 3. PV is equal to nRT. This is one of our gas laws. We need to get the equation to where it looks like R equals. Okay, so we're going to look at the side that R is on, and we see that we need to get rid of the N and the T, and they are multiplied by R, so we are going to do the opposite, which is division. So we're going to divide by N and divide by T, both sides. The N's go away because N divided by N is 1. The t's go away because t divided by t is 1, and we're left with r. So our final equation is r is equal to p times v divided by n times t. Number 4, we need to solve for c. So we're going to look what's next to it, and it's a plus 273. So we need to do the opposite of addition, which is subtraction. So we need to subtract 273 from each side. Okay, now when we do that, 273 minus 273 is 0. C plus 0 is C. So C equals K minus 273. Density is the mass of substance per unit volume. So I'm going to write that in the equation down here. It's mass per unit volume. The units that we use for mass are grams, and the units that we use for volume are milliliters. We could also use cubic centimeters for volume. So the units for density is grams per mil or grams per cubic centimeter. The density of water is 1 gram per milliliter. That means one gram will take up 1 milliliter of volume. So when will something float on water? If the density of a substance is less than the density of water, it will float. We already know that the density of water is 1.0. So if the density of a substance is less than 1.0, that substance will float on water. When will something sink in water? If the density of the substance is greater than water, the density of water is 1. So if the density of the substance is greater than 1, then it will sink in water. Now let's do a couple of density problems. All right, the first thing I do is I read it, and then I underline problems and circle what I'm looking for. So a certain solid has a volume of 35.7 cubic centimeters and a mass of 85 grams. What is its density? So I'm looking for density, so I'm going to write my formula over here. Density is equal to mass divided by volume. I know the mass is 85 grams and the volume is 35.7 cubic centimeters. I'm just going to plug that in. Density is equal to 85 divided by 35.7 cubic centimeters. That happens to be 2.38. Okay, and some other numbers. Grams per cubic centimeters. Do not forget your units. Okay, we're not done yet. All right, look, this number, 85, has two significant figures. This number has 3. So when we divide them, then we need to take the least amount, which is 2. So our answer can only have 2 significant digits. We're going to underline the first 2. Look at the one just to the right of the last significant digit. If it is 5 or greater, that means the 3 has to be rounded up. So our answer is 2.4 grams per cubic centimeter. All right, we're going to do the density of gold is 19.3 grams per mil. What is the volume of 200 grams of gold? We know the formula for density is mass divided by volume. We need to get volume all by itself. We've already rearranged that, so I'm going to go ahead and put volume is equal to mass divided by density. Our volume is what we're looking for. Our mass is 200 grams. And we're going to divide that by our density, which is 19.3 grams per milliliter. So I'm putting it up here, grams per milliliter. All right, grams divided by grams is 1, so I can make it go away. 200 divided by 19.3 is 10.362, and some other numbers. And we have a milliliter here. All right, okay. We need to find out how many significant digits we have. So this value right here has 3. This value has 1. So our answer can have no more than 1 significant digit. I'm going to underline that. So we keep the 1, and we need to get rid of everything else. The number right next to it is a 0. It's less than 5, so I don't round this up. There we go.